Okay, so today we are doing a little bit of review, and then we'll be doing the sum and difference formulas and the double angle formulas to add to our big list of stuff you got to know for this test. We already have a bunch of identities like sine squared plus cosine squared is equal to, what is sine squared plus cosine squared? 1, good. And then there was a couple other ones that are kind of similar to that, like one with the one with the tan, 1 plus tangent squared. What's the one with the tan? Seek. It's what you seek. And then lastly, the one with the coat, appropriate for Minnesota. One with the coat is cozy. Anyway, we're going to add to that a few more today that are the double angle ones. Okay? And that's going to be like this. Not sine of theta equals something, but the sine of 2 theta equals something. And it's a double angle. You get how the angle has been doubled? That's called a double angle. So we're going to do sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. You'll have to memorize some of those, but not all of those. Those are actually like hard enough that we don't make you memorize them. So we'll give you some of those. All right, so anyway, the last one I'm talking about right now is the sum and difference formulas. But this is kind of like that, so we started with this. If we wanted to do cosine of pi over 2 minus pi, first you figure out where pi over 2 is, which was here. And then if I go minus pi, I would actually go around this way and get to that spot. What's this spot? That spot is at what comma what? It's at 0 comma negative 1. And is cosine the x or the y? Cosine is the x, which would be 0. So the answer is just the same as it would have been up here. All right. Let's do another one like that. Would you figure out tangent for me of pi? And then I'm going to have you figure out tangent of pi plus something. But for right now, just figure out tangent of pi. I'll pause for a second while you're finding the tangent of pi. Okay, that should have been pretty quick, because here's where pi is. And I can't do a triangle when I'm over here. I mean, how would I do that? Like go up this way or something? But this has there's no length there. So I used to try to do it with showing people a triangle with a side of 0. But I think it's easier to just look at this point and say, oh, that on the unit circle, that would be the point, negative 1 comma 0. Raise your hand if you had that part right so far. Good. And is tangent the x over the y or the y over the x? Y over the x. And that's 0 over negative 1. Is that okay to do it that way? 0 over negative 1? Yes, it is. 0 over negative 1 is okay. It's just if there's a 0 on the bottom that we'd have a problem. So that answer is 0, because 0 over negative 1 is 0. So this answer was 0. How about if I say pi plus pi? Now that just rotates you another pi, another 180. So now you're over there. Is the answer going to be exactly the same? Well, you aren't in exactly the same spot, so let's think it through. What is that point? What comma what? Figure out what that point is. Then figure out tangent of that spot. All right. That spot is 1 comma 0. And now y over x is 0 over 1, so it's 0 again. So, didn't change much. Is the answer that these are all the same as each other? No. It really depends on the problem. All right. If I add pi, though, it seems like we end up often getting the same thing. All right. What if we were at tangent of 3 pi? No, let's actually do this one. Of 2 pi over 3. First find that one, and then I'm going to ask you to do like plus pi, and we'll see what happens. Just find tangent of 2 pi over 3 for right now. I'm going to pause while you figure that out. Okay, so the sheet I have put up on the board, I am also going to post on the Schoology. And this is the master sheet of all of the identities that you have to be able to use and have to be able to know for the next test. Okay? And I know I've been making you write them out, partially because it will be easier for you to remember it if you write them out. Engages a different part of your brain that's got better memory than just your visual. All right, so if you just look at this sheet, it's very difficult to memorize it. Writing it out does help you memorize it. All right, so I hope a lot of these are like the back of your hand now. Like those, sine squared plus cosine squared equals 1, and the one with the tans, what you seek, etc. Those got to be just down cold. So when you see secant squared minus 1, you're able to go, oh, that's just this one rearranged. What is secant squared minus 1? Got to be equal to what? Tangent squared. Okay. Or if you see a cosine, you got to be able to say, oh, that could be a 1 over secant. All right. So this sheet I'm about to post has a section on it for the ones that we are talking about right now. Think about this. If you have sine and you were doing some angle, but then you added 2 pi to it, wouldn't you be back in the exact same place as you were before? And therefore, it would just equal sine again. In other words, it wouldn't be any different if you added 2 pi to it. For cosine, same deal. If you add 2 pi to it, you're going to get the exact same things. So adding 2 pi, it shouldn't be a big surprise that these all come out the exact same thing as they were before. But what about adding pi? Tangent is kind of like this, except for cosine and sine, and their sister functions. If you add 2 pi, you're back where you were. But for tangent, did you see on that one example with tangent that if you add pi, that's what gets you back to the same spot, not 2 pi? So again, if I was doing tangent and I was here, and I go pi radians around here, I'm going to get the same exact answer as I had before. This was at 0, 1. This was at 0, -1. And for tangent, you want to only add pi, and you'll get the same answer as you had before. What was the tangent of this spot? Y over x, and so it'll be undefined. What's the tangent of that spot? Y over x would be undefined again. You get the same exact answer. All right, so for adding 2 pi, it makes sense to most people that, yeah, if you add 2 pi, you were here, you add 2 pi to it, you're just going to be right back where you were, so of course the answer is the same. But for tangent, it's only adding pi. All right, so I've talked you through those. How about the double angles? They're right here. There's a list of them. And we aren't going to expect you to memorize all of them, except I will tell you that on the AP tests, there are a few that they figure are likely that just they would expect you to know and wouldn't tell you. This is one of them. Probably because it's just so easy. Sine of 2 theta is the same as 2 times sine times cosine. What that means is, if you're in the middle of a problem and you see sine of 2 theta, and it's like over, oh, I don't know, 2 sine theta, you can replace 2 sine theta with that, 2 sine cosine. And then do you get a bunch of stuff would cancel if I did that? If I put in 2 sine theta cosine theta, because they're equal, now, oh, I could cancel off that part. I guess the answer is just cosine. All right, so these are a bunch more things to memorize, but I just said it, and I'll say it again. You're going to have this sheet on the test. Does that mean, well, what's the point of this? It's still a very difficult test. The test is not difficult because of memorizing stuff. The test is difficult because of having to go from point A to point B. If they say, in fact, we need to do a problem that is a typical question. We're going to do a lot more problems together with people in class, but a typical question might be something like, prove it. I hope this is an easy one for you. It should only take you 2 steps. Remember me saying that you can either touch the left side or the right side, but you can't do both? Do you remember me suggesting that one way was usually easier? You take the more complicated side and you simplify it down. So I would recommend you take the left side, simplify that puppy down, and it should equal 1. How many of you have already got it? Raise your hand if you already have it. Okay, awesome. That's like a third of the class. For those of you that are a little behind now, do you get that this has to do with that saying the one with the tan is what you seek? So then I take that one and go, okay, well, I'm going to write it down. 1 plus tangent squared is equal to secant squared. And then I would think about how could I rearrange that thing and like what substitutions could I make? And once you see it, you're like, oh, it's really easy. If you haven't got it by now, I'm scared for you a little bit. The secant could be replaced with what? 1 plus tangent. So your first step would be to go like this. All we did was replace that with that. And if you help me by drawing that, I'm more likely to see what your proof is like when I'm grading your test. I just replaced that with that. Okay. Then, can I just say equals 1 and I'm done? No. The finish on these things is that the left side needs to equal the right side. So you simplify this, which it's true, simplifies to 1. And how I check them is this. I look at the ending and make sure they wrote that, because if they didn't write that at the end, if there aren't two identical things at the end, then they didn't do it right. Next, I check and see, okay, is this really equal to this? And I kind of go backwards. And yeah, that is equal to that. And then, is this stuff here really equal to this stuff here? And I try to see what their substitution was, and oh, they just swapped out the secant with the 1 plus tangent, and that's legal. Okay, they did it right. That is a typical, super easy one. They get much more complicated, of course. All right, so this double angle thing, this sheet right here, I'm going to be posting. Double angles is the thing for today, and also these. Once I've explained those to you, then you now have everything that's on this sheet that you need, and you'll have talked about it a little bit. But how could you see something like this in a question? Let's say they said, that's not going to work. Hold on, I'm going to pause for a second while I make up a good proof. Okay, I oversimplified this a little bit, but let's say this was the question. Prove that this is equal to this. Again, this is a really easy one. So you look on your list and you go, okay, where is there anything on this sheet that is similar to this? Right there. And what do? I take the more complicated side. Is that the left or the right side? The left side is more complicated. I take the left side and I simplify it down and try to make it the same as the right side. So do you see the simple substitutions that I made? What is 1 over secant the same as? Cosine. And what is 1 over cosecant? Sine. Oh, that should have been y. Sorry, that wasn't messing you up. All right, and then look at that. This and this plus that and that, that's exactly what this says right here. So once I've rewritten this, sine x cosine y plus cosine x sine y is equal to sine of x plus y. All I did was swap out things I know are true. They're identities. That's equal to that. Then this statement, I know it's right off the sheet. Now, would it be that simple? No. That's a really easy one. Maybe these could have been written backwards. You know what I mean? Because when you add, do you get if I had to reverse the positions of these two, it might have made it a little more confusing. But all it would be is like switching the left side and the right side, and that's not hard for you to do. Like if this had been backwards, that would still be equal. Okay, so again, I don't see much point in trying to make you memorize all of this if I know that at the end you're not going to have them all memorized, except for this. Do you get that if you have two kids, one of which has got a lot of this memorized and the other of which doesn't, when I just say sine and they go, okay, what do I know about that? It's 1 over cosecant. I got that in my head. It's going to be a lot faster for them than just finding sine on this sheet. You know what I mean? You're just going to be more fluent with it. And if you're asking yourself, which partner would I rather have? Somebody who's got some of these memorized? Do I expect you to know all the complicated ones like this? No, I don't even have this memorized. I'm going to look it up on the sheet. That's okay. But at least I know where I would find those things that are sine of x plus y. There's a whole bank of them. They're this kind. All right. How about the cosine of 2x? Well, it'd be cool if you knew one of them. If I was going to pick anything to know, it would be this one, because this can be simplified down to this, which can be simplified to that. Those three all can be like derived from each other. So just like I suggested that you memorize a few things on this sheet at the beginning, and then you can get the other ones from those, I'd say the ones that I would expect you to know if we were done with this whole unit and you kind of knew them like the back of your hand, you should know that one. This one. This one I'm going to even use a different color. It'd be great if you could remember this is cosine minus sine. Okay. Then higher up, this is going to mess things up, but the ones I really expect you to know, all of these like the back of your hand. Those like the back of your hand, they come up all the time. And this one, because you can get these two from this one by just dividing them all by sine squared or dividing them all by cosine squared. Those can give you these. I will circle these in green also like I was doing before. It'd be nice if you knew those two. And I even gave you the sayings. One with the tan is what you seek, one with the coat is cozy. Okay, if you had those memorized, the rest of them, I could totally see you looking up on the sheet. We used to make kids memorize this one too. And I'll tell you the secret to it. As you're looking through, they all have negatives on both sides, except these. On this one here, they're missing the negatives. There's no negative here, there's no negative here. Now, I can show you where all of these things are derived. It takes a really long time, and I think our time would be better spent actually practicing using them, okay? All of these can be proven, and they can all be, and again, I'd like to show you some here and there, but I don't want to show you how to derive all of these, but I want to show you the one difference between these two. Let me show you what I mean. If I asked you to find sine of an angle like 30, by now, if you can't find sine of 30, I'm scared for you. Opposite, hypotenuse, 1, 2 square root of 3. And if I ask you to find sine of 30, do you get the answer as 1/2? You with me there? Okay, if sine of 30 is 1/2, what's sine of negative 30? Well, then that would be down here. And we've gone from A, S, T, C. Do you get by saying sine of negative 30? I moved you down into this quadrant. Is sine positive down there? No, sine of negative 30 would be negative. Look at sine of negative 30 would be negative. See what they're saying there? How about cosine? If I look at this original little triangle here and I said, what's the cosine of 30? 1, 2 square root of 3. Cosine of 30 is adjacent over hypotenuse. It's root 3 over 2. Do you get if I go down a quadrant with cosine and say, what's cosine of negative 30? And I'm down here. Do you get how, since it's all students take calc, that cosine is positive down there? See, cosine is positive. Even when you do the negative angle for it, cosine of the negative 30, which would be this guy, still comes out positive. Why? Well, the sides are all positive, the ones that we're using. That's a -1, and that's the square root of, or that's 2, sorry. So then cosine here is adjacent over hypotenuse, which is the square root of 3/2. I didn't use any negative numbers. It's still positive. So anyway, I don't need to show you where all of these are derived, but you need to be able to find them. And the reason they're called odd even is that the functions that are odd will all be one way, and the functions that are even are the other way. And it boils down to this. Do you remember this rule? Do you remember that being the odd rule? Do you remember the even rule was this? This was the even one. This is the odd one. I totally get. We haven't done this in so long, you might have forgotten these. I said, oh, there's negatives on both sides. That's odd. I don't know if you remember that, but anyway, this is the odd rule. And if I use that on these guys, I hope you can see ones where they have a negative in here and there's a negative out there. So therefore, sine must be an odd function. And it is. If you look at the graph of it, it's got the right kind of symmetry to be that. Okay, so which are the even ones? The even ones are the ones where they don't have a negative over here. And so this one would be an even one. And its sister function, of course, is an even one. So cosine is an even function. Let me show you a sketch of what cosine looks like. Do you remember cosine? Looked kind of like, maybe you don't remember this. That's sine, actually. And cosine was shifted over a little bit. We're going to get in a lot more of that in the next chapter. But one thing at a time. If that's cosine, do you remember how, if that's cosine, things that had symmetry that are exactly like the same across from each other like this, like just look at that part of the graph right there. Do you get this perfect symmetry across that axis? That's the kind that were even. So, yes?
Can you draw like a circle around the middle point and then you know what I mean?
Nope, I don't. I'm getting crushed on time because, so if you want to talk to me about that later, I'm willing. All right, so I tried to show you a little bit about where these things came from. This is your like big bank of stuff you can use to solve problems. All right, so let's see now how we might use this to solve some of your homework problems for tonight. So everybody find this page on the smartboard for today. It's way down in there. Can somebody tell me what page number that is on your slides? 20? Everybody find page 20, please. All right, now I'm going to have this up on the side because you'll need it. You'll need to know which one. Well, let's look back and forth here. If I'm supposed to be, and I'm assigning this whole front page here, okay, this page, the blue page, problems 1, 2, 22, all right, sine of 3 theta minus 2 theta. If I go in here, or sorry, 3 pi minus 2 theta. If I go onto my sheet, I got to find one where I have sine of something being subtracted. I'm going to look on my sheet. I'm going to look for something where sine of something being subtracted. Ooh, that's something being subtracted. Maybe that's the one I should use. Okay. Oh, wait, there's something else. Here's sine of something being subtracted. Maybe that's something that I should use. Those are the only two where sine has something in its parentheses being subtracted, right? So it's one of those two. Now let's go back over and figure out which one might work. Three pi minus 2 theta. And it's supposed to equal negative of that. Oh, interesting. That's got a negative on the outside with the sine. Do you get how that kind of looks like one of those identities? Which one? Actually, there's another one up here where there's sine with a negative on the out. This one, that's another one of the one of the identities that might be it. So how am I supposed to know? Because see, I saw this negative in front of the sign, so I knew that might be the one they're talking about. So how do I actually solve this? I gotta look at the directions, and it says use the even/odd identities. Oh, if it says I have to use the even/odd identities, I guess that's this one. That must be the one I should use. Do you get how there was 3 things that caught my eye, though, on the sheet? And that's how you're going to have to fight through it, too. They said in the directions, use the even/odd. Oh, so these are the even/odd identities. I have to use this one. Okay, so now how do I actually use that?
Like the holiday?
I'm looking at the time, and I'm very loud in the hallway. Hold on just a second here. Okay, so remember, there's an answer key posted. I feel bad leaving you with like not showing you exactly how to do this, but then again, these are difficult. You need to fight your way through this. Tomorrow, now that you've been introduced to all the identities, tomorrow we're going to spend a lot more time actually working problems from easy ones to medium ones at least. And then the next day, hopefully, we'll be moving from up to the hard ones. And then your test will be a bunch of medium ones, not incredibly hard ones. But we're not going to have many easy ones on the test. All right. So for tonight, just do this first page, which has 3 questions on it, and yep, you could do this one too. It says 3 minutes. That means it's not super challenging. Otherwise, you're kind of missing the point. Right away, I'd go to my sheet where it says cosine of A plus B. I'd look on the sheet and go, okay, well, which identity is this? And I got to use this stuff in the directions, otherwise I can't possibly answer the question. It says it's in quadrant 2. I hope you know that's this one. That's out, that's out, that's out. And it says that cosecant of A is 3. No, wait, no, I'm sorry. There's 2 different angles here. There's alpha and there's beta. Beta is in quadrant 3. Okay, so I'm doing beta right now. Beta is in quadrant 3 with a tangent of beta is -7. How is that possible? Remember, they've always given you 2 sides. I'm going to put it over 1. Tangent of beta is -7 over 1. Can you make a triangle where its sides are 7 and 1? Yeah, you can. Because the opposite and the adjacent sides can be 7 to 1 ratio. So you make yourself a triangle where the opposite side is -7. The adjacent side is 1. Okay, but wait a minute. My negatives got messed up. Just because I threw the negative on top, couldn't the negative have been on the bottom? Sure it could. So that part's negative and that part's positive. Because they told me I'm in quadrant 2, it has to be that way. But when I divide them, it'll give me a negative. Could I figure out the third side? Yeah, you probably should. There's the beginning of it. Now I'm going to take and figure out alpha. Alpha's this part, and it says it's between 0 and pi over 2. Here's 0, here's pi over 2. So I'm in this quadrant right here. So hopefully you can draw a triangle in there, and then you can figure out cosecant. Oh, ick. I'm going to put this over 1. Cosecant, I don't like doing cosecant. So instead, don't do cosecant. What's the sister function that you could do? Sine. And again, if you don't have that and you have to look on a sheet, that's taking too long. Cosecant's the same as sine, or sister of sine. So really, this is the same thing as saying sine of alpha was, flip it, 1/3. So now I can draw my triangle. And then when it's all over with, I have to figure out this. you better go look at the sheet and say what that's equal to. Cosine of alpha plus beta? Oh, it's on the sheet over here. Where is cosine of alpha plus beta? Which of these looks like that? Ooh, here's one. Cosine of x plus y. Do you get, even though it doesn't say alpha and beta, that would be the one that would apply? All right. That's all I got for you for today. I understand it's a little rough right now. We'll do some more practice problems tomorrow. Make sure you do your part. Get that homework done, and there's an answer key, so there's no excuses.